Question 2a. Write down an equation to describe what physicists mean by the word efficiency. Well, it's useful output energy divided by total input energy. Output over input is not sufficient. You must talk about the useful output energy over the total input energy, and the word energy must be referred to. Part 2. The useful output energy from an electrical generator is 150 kilojoules, and the wasted output energy is 450 kilojoules. Use your knowledge of the principle of conservation of energy to calculate the efficiency of the generator. Why are we referring to the principle of conservation of energy? Because it states that the total energy in a system is always constant, so energy cannot be lost, created or destroyed. It is changed from one form to another. What this means then is that the total energy is the useful output plus the wasted output. So total energy input, some of it goes to useful output, some of it goes to wasted output. So we say total is useful plus wasted. The useful was 150 kilojoules, the wasted was 450 kilojoules, so the total energy input to it is 600 kilojoules. Therefore, efficiency is useful output, which is 150, divided by the 600, which is 0.25. So the efficiency is 0.25. You may also wish to express this as a percentage, which is totally fine. In that case, it would be 25%. Marks for this question: you get 1 for working out the total energy, 1 for using the efficiency equation, and 1 for the final answer. Same question, B part 1. Below are 7 different energy resources: biomass, coal, gas, geothermal, hydroelectric, nuclear and wind. Classify them by writing the name of each of them in the appropriate column in the table below. We have 2 renewable columns and non-renewable. So there's renewable and dependent on the energy of the sun, renewable and independent of the energy of the sun. Let's start with the non-renewables, get them out of the way. Nuclear, coal and gas. And what I would actually recommend is score them out as you go along so that you don't miss any. When we look at the 4 left, we have biomass, hydroelectric, geothermal and wind. There's only one which is independent of the sun, and that's geothermal. It, of course, is the heat contained within the earth. Biomass, hydroelectric and wind are all related to the sun's energy. So we fill them in here. And ensure that you've got all the answers. There's half a mark there for each one being in the correct place. Part 2. There's an increasing interest in the use of biofuels for energy. Biofuels are frequently obtained from the oil-bearing seeds of crops like rape and maize. What form of energy is stored in biofuels? Same as for any fuel. Chemical. Explain carefully why biofuels can be thought of as renewable sources of energy. Renewable sources, our definition of renewable is that they can be replaced within a lifetime. That would be our standard definition of renewable fuels. The mark scheme also gave the following explanation. The sun's energy is converted by photosynthesis, and the sun's energy will never run out. This section was the mark scheme, answer. So I would advise that whenever you're asked a question like this in the exam, not only do you state the definition that we have learned, which can be replaced within a lifetime, I would also link it back to the sun's energy and the fact that the sun's energy will never run out. So I would advise that you give all of this as a standardised answer in the exam. Even if in the exam in future they only look for this definition, the fact that you're backing it up with this extra information will ensure that you get the marks, especially in a question where it says explain carefully. They're obviously looking for detail there. Question 09, paper 1, had a second question on energy, and this one focuses mainly on work done. In a swimming competition, an athlete swims 400 metres at a steady speed of 0.8 metres per second against an opposing force of 450 newtons. Write down an equation which will enable you to calculate the work done by this athlete. Well, we're given force and distance, and our standard equation for work done is force times distance moved. If you used work done equals F times D, that's also fine. Use the equation in part 1 to calculate the work done by the athlete. So work was a force of 450 newtons. She travelled a distance of 400 metres, so it's 180,000 joules. And always make a point of writing your answer into the correct place. The swim lasts for 500 seconds. Use your answer in part 2 to calculate the power. Well, power is work done over time taken. So it's 180,000 divided by the 500 seconds, which works out to be 360 watts. Now, if you had miscalculated the answer to part 2, but you used this figure correctly in part 3 with the correct equation and worked it all out correctly, you would still get your 3 marks. What are the 3 marks for? 1 for the equation, 1 for putting the values in the correct places, and the 3rd mark for the final answer. Part D. From the early 20th century until the present day, there was a very significant rise in the amount of carbon dioxide in the Earth's atmosphere due to increasing use of fossil fuels. This has caused a rise in the average temperature of the atmosphere, and this effect is called global warming. Explain how a rise in the level of atmospheric carbon dioxide has brought about global warming. Now, this is very similar to the previous question you were asked. Heat from the sun is absorbed by the earth. And re-radiated into the atmosphere. Where it is absorbed by CO2 and reflected back to Earth. This trapped heat warms the Earth. What you need to identify is the re-radiation of the heat into the atmosphere, the fact that the CO2 then traps it and reflects it back to Earth, and the fact that this then warms the Earth. So the re-radiation, the trapping, and the warming of the Earth. Any 3 out of those points will get you the